So factoring was the first method we talked about. And again, we just do our normal factoring thought process. Is there GCF? No. Is there a difference of squares? No. Is there a sum or difference of cubes? No. Is it a regular, special trinomial? No. Regular? Yes. Grouping's the last one. Okay? So, this is an easy one because A is 1. So we can just go ahead and do that. Make our two sets of parentheses. It's got to be x squared when A is 1. X times x. When 10, the C is negative, 1's addition, 1's subtraction. So what are my two numbers, Chris Walsh? Right. Positive 5, negative 2. They multiply to give me negative 10 and add to give me positive 3. Any questions on the factoring method? Now, we're not finished. Remember, it's saying this times this is 0. That means x plus 5 equals 0, or x minus 2 equals 0. One of those two have to be 0. So we figure out both equations to find both answers. So negative 5 is one answer, and positive 2 is the other answer. Okay, questions? All right, so solve by factoring, simple. Next one, solve by the square root method. Okay. So when we do the square root method, there's usually no x in it. So we just get the x squared alone, and then we'll take the square root of both sides. Right, Carter? Mm-hmm. So we're going to subtract 20 first to move that over. And a lot of kids at this point will try to take the square root because they said, well, 4 is a perfect square, so I can take the square root of it. Don't do that. Take the 4 to the other side first. Just get the x squared by itself. Now take the square root of both sides. Okay, when you take the square root of both sides, Kennedy, what do you got to remember? Yeah, you need that plus or minus symbol. And then, what's the square root of negative 5, Michael?
Negative 5, that's I.
What else?
Square root 5.
Yeah, thank you. Okay? Square root method. Questions? Make sense? Soaking it up? If you forgot? Okay. The third method. This is the one that usually gives you guys, my past students, but not you guys, because you guys are much better than all my past students, right? And all my other ones this year. You're the best class, right? All right, completing the square. All right, Jamie, what must be true? Pressure's on you, we're all watching. Yeah, what's the first thing we got to make sure before we can complete the square? You got your notes from yesterday? Did you write down what I wrote down up in the corner? Oh. John, you remember? What must be happening for us to use completing the square? Cody.
Is it x less than 1?
The A, the one in front of the x squared, yeah. That has to be a 1. So that's the first thing you look at. So are we okay with that? We're there right now, right? What's the next thing we do? Once we see that that A value is 1. What do we write? Ashton? What do we write when we want to complete the square? Instead of checking Instagram and stuff and posts. By Michael?
Yeah.
Right?
Yeah, well, X will be in there, sure. Yeah. That's good. What do we gotta do? Chris?
We really make a lot of
Yeah, we gotta add a blank. We take the C value over, so we add 10. So on the right side now it's positive 10, and we add a blank to both sides. What we're doing here, we're completing the square. We're making this one of those perfect square trinomials, one of those special ones. Okay, and like Chris said, it's B over 2 squared. So what's B over 2 in this problem? What's B divided by 2 in this problem? 4. And what's 4 squared? 16. So 16 goes here. Okay? So what we did then, since we made it one of these special trinomials, we can factor it to look like this. 1 binomial squared. And the binomial comes from the x squared, the square root, and the 16 square root. And then whatever's in front of the b goes between. And then on the right, just add the 2 numbers. And that's what our problem looks like now. So now what do I do to both sides? Square root, yeah. So now we've turned it into a square root method problem. We complete the square first, and then we use the square root method to finish it up. So we get x plus 4 on the left. The square root of something squared is itself. Don't forget your plus or minus. And simplify this, but when you do your factor tree, it's just 2 times 13. You can't pull anything out. So to finish up, just subtract the 4 on both sides, and we're done. I like to put the number in front of the radical, so I always write it -4 plus or minus square root 26. So that's a quick review of what we did yesterday and what you had for homework yesterday. Okay? For those of you that did it, here are the answers. For those of you that did it without Slater. Number 3 is -1/2 and 1. Number 6 is 8/3 and 3/4. And number 9 is 2 and 8. Now number 9, if you got that problem, I would have you do it by square root method. I wouldn't make you do that by factoring. Okay? It's a difference of squares, but I would just tell you to add 9 and then take the square root of both sides. You get x minus 5 equals plus or minus 3, and then add 5. 5 plus 3 is 8, 5 minus 3 would be 2. So 2 and 8. Questions on 3, 6, or 9? 6 was kind of a big numbers, but it's still factorable. 12 is plus or minus 15. 15 is plus or minus 2i. 18 is -15 and a positive 7. Any questions on any of those? And then 21 is -3 plus or minus 2 radical 2. 24 is -4 and a positive 2. 27 is -3 plus or minus the square root of 13. That's the numerator, and the fraction bar, and the denominator is 2. And 30. This is the numerator, -5 plus or minus the square root of 31, and that is also over 2. All right, I'd like to look at 30 if there's no other questions on any of the others. Because 30 has a couple things in there that you got to make sure you do when you complete the square. So if you run into one like this on our practice quiz or quiz this week, you'll be able to do it. So this one is 2x squared plus 10x minus 3. So there's our problem. What do we gotta make sure of first, Jamie?
Or the one, but it's a one.
Yeah, and it's not a one, it's a two. So how do we make it a one? Divide by two. Whatever that number is, just divide everything by that. Because anything divided by itself is what? One. So that's why we do it. Come on, man. So I got my x squared. 10 divided by 2 is 5x plus blank. I'm taking my c value, negative 3/2 to the other side, so I'm going to add it. So it's positive 3/2 on this side. Now, what else is kind of tricky about this is that our b value is what? 5, odd, right? Right? So make sure we're focusing here. Too many people looking at phones and at laptops right now. Okay, b is 5 over 2 squared. Just write it out. Okay? Just write it out when it's an odd one. And then just do it. What's 5 times 5? And 2 times 2. So you write 25 fourths then. Now, some of you might have put 6.25. That's okay. I just think in the long run, it's easier with the fractions than the decimals when you try to simplify it. Okay? So, now I made it special. I completed the square. The square root of x squared is x. The sign in front of the b is plus this problem. And the square root of that, which is basically what you just did, 5 over 2. You just squared 5 over 2. Now you're just rewriting it. Okay, to add these, you need a common denominator. We just got through a couple weeks ago, we need common denominators to add and subtract, right? So the common denominator is 4. So I multiply 2 by 2 to get a 4. So I multiply 3 by 2 and get 6. So 6 plus 25, 6 fourths plus 25 fourths is 31 fourths. So now I do my square root method, square root both sides. So we get x plus 5/2. Square root of something squared is itself, plus or minus 31. If we try to simplify it, it won't simplify, but what's the square root of 4? 2. So that simplified at least. So we got the same denominator now. I can just subtract 5/2 over and make it one fraction then. If you keep it as separate fractions, that's okay. Since they're the same denominator, I just make it one big fraction. So it looks like that. Okay? So that had a couple things in it. It had an a value that wasn't 1, so we had to make it a 1. And then a b value that was odd after we did that, so we had to write it as a fraction. 5 over 2 squared. Okay? So, those are the 3 methods. Factoring, square root method, completing the square, and then I told you yesterday there's one more. All right? This one's really easy. You guys have done this many times. Shouldn't be a problem. The quadratic formula. All right? So you guys might want to write it down. Negative b plus or minus the square root of b squared minus 4ac over 2a. Right? I always put parentheses in there, in that top part. That way our signs, even when I put it in my calculator, I use those parentheses. So my signs and my numbers come out correct. If you try to drop some parentheses, sometimes your signs get messed up. So, Brendan, what's my a value for this problem?
A value is 4.
Good. Liam, what's my b value?
-4.
Thank you. Tasha, what's my c value? Any questions on the a, b, and c value? So now you just plug those numbers in, right? So x equals negative b, which is negative 4, plus or minus square root of b, which again was negative 4 squared. It's always minus 4, right? That part's always the same, minus the 4. And then a is 4 and c is negative 3. And then remember, there's still a denominator. And then 2a. You guys all know how to do that, right? You've done that. Freshman year, did it last year, we're doing it again this year. Any questions so far? Okay, here's how I do it then. Some of you like to put all of that in the calculator. Don't do that. Don't put it all in the calculator, okay? You don't need a calculator for this. What's minus a negative 4? Thank you, guys. You guys are all on top of it. And you guys can do 2 times 4 without a calculator, right? Okay, here's where you guys make a mistake. You want to put square root of that. Now, if it comes out to be a perfect square number, it works out really nice. But most of the time, it doesn't come out to be a perfect square number under there. So don't put the radical in the calculator. Just do that part. We call that the discriminant. So just like it's done with the parentheses, negative 4 squared minus 4 times a times c. All right, just like that. You get 64. Well, this one was a nice number. So if you would have put the square root symbol in there, it would have given you a nice number. If that wasn't a perfect square, then you get all these decimal stuff. We don't want the decimal. We want it in radical form. But this one does work out nice. So since it does work out nice, finish it up. Don't just leave it as 4 plus or minus 8 over 8. 4 plus 8 is 12, right? Twelve eighths, which reduces to 1 1/2, 3 halves. Or 4 minus 8 divided by 8 is negative 4 eighths, which is negative 1/2. So if they come out to be nice numbers, go ahead and finish like I did. You guys remember how to do this, don't you? Any questions? Okay, the only other thing that show you here, they talk about the discriminant. All right, that's the discriminant. That's the part that's under the radical sign, that's b squared minus 4ac. Okay? It says use a discriminant to state the number of solutions. So they're going to give you a problem. And instead of actually finding the solutions, they're just telling you to state if it's got 2 real, 1 real, or 2 non-real. That's the 3 possible answers. So the first thing I would do is get it in the right order. So Chris, go ahead and put it in the right order for me. Chris Tekalowski.
Oh, x squared plus 5x plus 7.
Close. When we move that 5 over, what happens to it?
Negative.
Thank you. Very good, sir. So that's what we want to look at first. Put it in the right order so you know what your A, B, and C is. Okay? So then you're just going to do the b squared minus 4 a c. Okay? And I get 25 minus negative 4 times 1 is negative 4 times 7 is negative 28. So that's a negative 3. Okay? If this is negative like that, less than 0, there's 2 non-real solutions because you're going to take the square root of a negative so the I comes out, right? So that's an imaginary, non-real answer. Sometimes it'll equal 0. What's the square root of 0? 0, right? So if we had this problem, instead of a 64 there, that was a 0, it would be 4 plus 0 over 8 and 4 minus 0 over 8. That's the same answer, right? So that's why there's only one real solution when it equals 0. Come on. This technology is nice, but it's kind of a pain sometimes too. So for this, if we were doing this one, state the number of solutions, you would have said 2 non-real. But also, it could be less than 0 like we just did, it could be equal to 0, or it could be greater than 0 like it was a 64 there. And that means there's 2 real solutions, and we got 2 real numbers for our answer, right? So you have a couple problems. Well, all they want you to do is this part. And if it's a positive number like this, you'll say 2 real solutions. If it's 0, you'll say 1. If it's negative, you'll say 2 non-real. That's all. You don't have to do the whole formula. There's your homework. Eight problems. Not a whole lot, not too much for you. You can handle it.